approximating distributions, the normal approximation to the binomial distribution. Starting with a binomial distribution, if these two conditions are met, we can use a normal approximation to solve any probability problems. And we also apply this continuity correction. In this example, n is very large, and this value is not in the probability tables for the binomial distribution. Using the binomial formula is not practical. There are just too many probabilities to calculate. So we can use a normal approximation to solve this problem. So if we multiply n and p together to work out the mean of the binomial, we get 150. This value is more than 10, so the first condition is met. N is large, 200 is more than 50, so the second condition is met. In the normal distribution, we need a mean and variance. So we take the mean and variance from the binomial distribution and use those values here. We already have the mean, it's 150, so that value will go here. And if we work out the variance, np times 1 minus p, and the formula for this is in the formula book, we get 37.5. So our mean is 150 and the variance 37.5. So applying the continuity correction, px less than 160, so we want 159, 158 and so on. We don't want 160. The boundary in between what we want and what we don't want is 159.5. So in the normal distribution, we work out px less than 159.5. To calculate the probability, we standardize. So x is 159.5. The mean is 150. And the standard deviation is the square root of the variance. So we're looking for pz less than 1.55. So going to table 3 in the formula book, we get this probability. So this probability is the approximate value of px less than 160 that we started off with. Here is a graphical representation of the binomial distribution. And in blue we have the normal distribution that we're using as an approximation to the binomial. And as you can see, it's a very good fit because the two conditions here have been met. Starting with a binomial distribution, if np is less than 5, you go down this route to the Poisson. If np is more than 10, you go down this route to the normal distribution. If np falls in between 5 and 10, then you would work out the mean of the binomial distribution. So do n times p, work out the mean. If that value can be found in the Poisson tables, then use a Poisson approximation. Otherwise, use a normal approximation. For example, if np was equal to 6, 6 can be found in the Poisson tables, so this is the route that you take. If np was equal to 6.3, this value is not in the Poisson tables, then you would use a normal approximation.